नमस्कार विद्यार्थी मित्रांनो, एक्सपर्ट टीचिंग या यूट्यूब चॅनलमध्ये तुमचे स्वागत आहे. देन I will seen in the some definition of kinematics in a circular motion such as displacement, next angular displacement, and the next linear velocity, angular velocity, linear acceleration, and last one is angular acceleration. This is the some definition of kinematics in circular motion. Then first we can see the definition of displacement. Then the displacement is the shortest distance between the initial and final point. Now this is shortest distance. This is shortest distance between the initial and final point is called as displacement. Now, this is shorted, SHOR. Point number 2, it is denoted by X, Y and S. It is SI unit is meter. Now the displacement, the shortest distance between the initial and final point is called as displacement. In second point, displacement is denoted by X, Y and S. It is SI unit is meter. Then what is meant by shortest distance? This is the y-axis and x-axis. Then point A and the origin O. Point A and origin O is the distance is shortest distance. This shortest distance between the initial and final point is called as displacement. In Marathi, दोन बिंदूमधले कमीत कमी अंतर म्हणजे डिस्प्लेसमेंट होय आणि ते डिस्प्लेसमेंट एक्स, वाय आणि एस या अक्षराने दर्शवतोय. डिस्प्लेसमेंटचे SI एकक मीटर आहे. Now the second point is angular displacement. Angular displacement. Then angular displacement. Angular displacement means the angle between the radius vector in a circular path is called as angular displacement. Now the point, the angle between the radius vector in a circular path is called as angular displacement. Then we can see the diagram. now OP1 and OP is the radius of circle and the theta is the angle between the two radius of circle, that is OA and OP1. Then theta is called as angular displacement. P and P dash, P and P1 be the length of arc of circle. In Marathi, OP and OP1 या दोन वर्तुळाच्या त्रिज्या आहेत आणि या दोन वर्तुळाच्या त्रिज्येमधील जेवढा कोन होतो त्या कोनालाच आपण अँगुलर डिस्प्लेसमेंट असं म्हणतो. P आणि P1 याला आपण लेंथ ऑफ आर्क ऑफ सर्कल असं म्हणतोय. देन the angular displacement is Point 1, the angle between the radius vector in a circular path, that is in circular path, and this angle between the radius vector is called as angular displacement. In figure O, in figure the point 2 is in figure OP1 and OPB, the radius vector with angle between the radius vector is theta. Then we can see the diagram OP1 and OPB, the radius of two circle, and theta is the angle between the radius of two circle, and theta is called as angular displacement. Then point number 3, then it is given by the angular displacement is, now the angular displacement is, now the angular displacement is, see it's angular displacement is equal to length of arc of circle, is the length of arc of circle to the radius vector, length of arc of circle to the radius vector. In point number 5, it is given by theta equal to s upon r. Now theta equal to s upon r. Theta is the angular displacement, s is the length of arc of circle, and r is the radius of circle. Then the angular displacement is also be denoted as d theta, that is d theta is equal to ds upon dr. D theta is the angular displacement, ds is the small length of arc of circle, and dr be the small element of radius vector. Then d theta equal to ds upon dr. This is the angular displacement. In figure OP1 and OP be the two radius vector. Theta is the angle between the two radius vector. Then theta is angular displacement and d theta is the angular displacement. Then another definition is linear velocity. Now the another definition is linear velocity, that is linear velocity. The linear velocity means the rate of change of linear displacement with time is called as linear velocity. Now the point number 1, the rate of change of linear displacement with time is called as linear velocity. Linear velocity equal to displacement upon time. Then point number 2, linear velocity is denoted by v. The linear velocity is denoted by v, and it is given by v equal to dx upon dt. In point number 3, v equal to dx upon dt. dx upon dt means rate of change of displacement with time. Then the SI unit of linear velocity is meter per second. In point number 4, the SI unit of linear velocity is meter per second. Now the another definition is angular velocity. Now this is angular velocity. This is angular velocities. Same as the definition of linear velocities. Then the angular velocity is rate of change of angular displacement with time. Rate of change in point number 1, rate of change of angular displacement with time is called as angular velocity. Angular velocity is denoted by omega, and it is given by omega equal to d theta upon dt. In point number 4, omega equal to d theta upon dt. d theta means small element of angular displacement and dt means small time. Then The SI unit of angular velocity is rad per second in point number 5. The SI unit of angular velocity is rad per second. That is rad per second. Then the another definition is linear acceleration. Then what is meant by linear acceleration? The linear acceleration is point number 1, the rate of change of linear velocity with time is called as linear acceleration. Then linear acceleration is denoted by capital A or small a. Then it is given by, in point number 3, it is given by a equal to dv upon dt. In point number 4, a equal to dv upon dt. It is the linear acceleration. dv means change in velocity. dv means change in velocity and dt means change in time. Then a equal to dv upon dt is the total formula for linear acceleration. In point number 5, it is SI unit is meter per second square. Meter per second square, that is meter per second square. Now another definition, angular acceleration. Angular acceleration. The definition of angular acceleration is same as the definition of linear acceleration. Then the rate of change of angular velocity with time is called as angular acceleration. ज्याप्रमाणे लिनियर ॲक्सेलरेशनमध्ये आपण लिनियर व्हेलॉसिटीचा वापर केलो आहे, तसं या डेफिनेशनमध्ये अँग्युलर व्हेलॉसिटीचा वापर करणार आहोत. देन डेफिनेशन, angular acceleration is the rate of change of angular velocity with time is called as angular acceleration. In point number 2, angular acceleration is denoted by alpha and it is given by, point number 3, it is given by alpha equal to d omega upon dt. Point number 4, alpha equal to d omega upon dt. Then d omega means change in angular velocity and time dt. Then total angular acceleration is the rate of change of angular velocity with time is called as angular acceleration. Angular acceleration is denoted by alpha. It is given by alpha equal to d omega upon dt. Then it is SI unit. The SI unit of angular acceleration is rad per second square. This is the SI unit of angular acceleration. Angular acceleration SI unit rad per second square. Then today I will see the 5 definition. The first one is displacement. The displacement is shortage distance between the initial and final point. Then angular displacement, the angle between the radius vector in a circular path is called as angular displacement. Then this is diagram of angular acceleration. Then another is linear velocity with the rate of change of linear displacement with time. The rate of change of linear displacement with time is called as the rate of change of linear velocity with time is called as linear velocity. Now it is denoted by v. It is given by v equal to dx upon dt. It is SI unit meter per second. Then another is angular velocity. The angular velocity is the rate of change of angular displacement with time is called as angular velocity. It is denoted by omega and omega equal to d theta upon dt. In point number 4, it is SI unit rad per second. Then another is linear acceleration. Yeah, that is linear acceleration. The rate of change of linear velocity with time is called as linear acceleration. It is denoted by capital A or small a, and it is given by a equal to point number 4, a equal to dv upon dt. It is SI unit meter per second square. The angular acceleration is the rate of change of angular velocity with time is called as angular acceleration. It is denoted by alpha. It is given by alpha equal to, that is d omega upon dt, and it is SI unit rad per second square. Then tomorrow we can see another concept. Thank you.